Okay, so with that in mind, what's the relevant input then for learning this target knowledge about basically which WH dependencies are more or less acceptable in some sense by how much? And that, of course, depends on how we think it is that children learn that knowledge. So an intuition from Pearl and Sprouse 2013 was like, okay, here's how children could learn it. You learn what you can about WH dependencies from the dependencies you do actually observe in the input, whatever they are. And then with that learned knowledge, you can apply what you've learned to make a judgment about any dependency, including dependencies you haven't seen before, like those, say, that cross syntactic islands or maybe other longer dependencies. You have the ability to generate a judgment about things you haven't seen on the basis of what you have seen. So the learning theory then that was proposed by Pearl and Sprouse 2013 is a concrete learning strategy that says view WH dependencies in terms of their building blocks, which we'll talk about in a moment, and track those building blocks in the input, because that's what you're going to use to generate judgments about any dependency you like. So just to show you how that works, the dependencies under this learning theory are represented as a sequence of what Pearl and Sprouse called container nodes. That is, the phrases that contain the gap, but not the WH word. So in what do you see, you have the gap here, so the VP contains that, and then the IP contains the VP. And then the word what is contained by the CP, so you don't really have to include that, you're just trying to get to the what. So the phrases would be IP and VP for this WH dependency, and you can sort of flatten that, as it were, represented as just a sequence. In fact, you sort of start, and then it's IP, VP, and then you reach the gap end. Now, you can do this for any dependency, so for really short ones, like what happened, where it's just a subject in the main clause, what happened, right? It's just the IP that's containing the gap before you get to the WH word, so start, IP, end. You can do it for longer ones, right? Any dependency you like, so what did she want to do? Again, you have this sequence of nodes that contain the phrase before you get to the WH word, which we can write like this, start, IP, VP, end, right? And again, you can do this for any dependency you like, including, much less acceptable dependencies like this one. And so who did Lily think that the kitty for was pretty? And the idea is that these dependencies will have sequences or segments that are low probability, that are just not very frequent, right, in whatever way that you might get them from the input. And so that's what makes these particular dependencies less acceptable, and in particular less acceptable at these points in the dependency, if you kind of zoom in. So if children break these dependencies into smaller building blocks, they can identify if a dependency has bad segments, right, one or more bad segments made up of one or more low probability pieces, low probability building blocks. And so the building blocks that Pearl and Sprouse proposed were what we can call anyway, syntactic trigrams, just trigrams of container nodes. So just to show you what that looks like, if you have a dependency like our first one, what did you think? Start, IP, VP, end. You can break this up into two sequences, overlapping sequences of 3. So this is a trigram, a sequence of 3. This is a trigram, a sequence of 3. And between the two of them, they cover the entire dependency. And you can do that for longer dependencies, which in fact this one involves the same 2 pieces plus a couple of additional trigram pieces. You can do it for really short ones, right? That's just one little trigram piece. And of course you can do it for, in this case, an island crossing dependency. It's going to have some of the pieces you've maybe seen before, and then again pieces that maybe are very low probability. These are our bad segments, our bad building blocks, right? And so the strategy is just to track the relative frequency of these building blocks, of the syntactic trigrams in the input. And after a while, after you see enough input, you're going to realize that some of them are more common and some of them are less common, though maybe still there, right? As opposed to ones that maybe are never there, building blocks that just aren't there no matter how hard you look, right? Or they're super infrequently, right? If, maybe because of a mistake. And so the way that Pearl and Sprouse aggregated this information was to say, okay, the probability that you're going to calculate from this is just count the number of total trigrams of whatever type and divide it by all the trigrams, smooth a little bit so that you don't actually end up with a 0 probability if you never see a particular trigram. You just end up with a really tiny probability. And so that's how you calculate probability of these building blocks. And then when you want to figure out how probable, how acceptable a WH dependency might be, you can construct that dependency from its syntactic trigram building blocks, right? So here's we would construct it from this, and in this case, Perl and Sprouse propose that you just multiply them. It's a simple aggregation strategy. There are other ones you can try, but this one worked, so this is what they did. We did, right? And so you're just multiplying these probabilities to get a sense of what is the probability of that dependency, any dependency you like, right? So you can do it for ones that have very common pieces. You can do it for longer ones that have common pieces and maybe less common pieces. You can do it for ones that have common pieces but also really uncommon pieces, right? So same process, you just multiply the probabilities of your different syntactic trigrams, your different building blocks that you've collected from your input. And then again, the idea is that that probability that you are calculating for any WH dependency, whether you've seen it before or not, can stand in for its predicted acceptability, how acceptable you might judge it to be in these kind of estimation judgments that we saw earlier.